Okay, today we're going to look at a problem involving a quadratic function where we are asked to maximize or minimize a quantity. So the problem reads, if an archer shoots an arrow straight upward with an initial velocity of 160 feet per second from a height of 4 feet, then its height above the ground in feet at time t in seconds is given by the function h of t equals negative 16 t squared plus 160 t plus 4. We're asked to do two things in this problem. We want to find the maximum height reached by the arrow, and we also want to find how long it would take for the arrow to reach the ground. So we're going to be doing both of those things. We'll do part A first. So we're given the quadratic function. That was pretty nice of them. They put it together for us. They could have made it a little bit more challenging by having us construct that function ourselves. So if you'll notice the numbers that are provided, the initial velocity of 160 feet per second and the 4 feet end up in our function in particular spots. So the initial velocity of 160 feet per second becomes the coefficient of t in that function, and the initial height of 4 feet becomes the constant term. And the negative 16, the coefficient of t squared, that number is related to gravity. So the positive terms of 160 and t and 4, those are quantities that are pushing the arrow up above the ground, and then gravity is pushing the arrow back down towards the ground, hence why that term is negative. In either case, the function is quadratic, and we are asked to find the maximum function value for that quadratic function, right? We're trying to find the maximum height. And anytime you're ever asked to find a maximum or a minimum for a quadratic function, that quantity can be found at the vertex, right? So the maximum or minimum is always found at the vertex of a quadratic function. So the formula for finding the vertex in this case is x equals negative b over 2a. This helps us find the x-coordinate of the vertex. But in this case, the x-coordinate is not called x in this particular problem. The x-coordinate is called t, right? So our x-coordinate in this particular problem is the time variable. So maybe we should use t here to describe that. So let's go ahead and find the time it would take to maximize the height. So the value we're about to get is not the maximum height. We are finding the time it would take for the arrow to reach its maximum height. So in this quadratic function, b is equal to 160 and a is equal to negative 16. So plugging those numbers in, we'll get negative b, which is 160, over 2 times a, which is negative 16. Right. Simplifying this, we end up getting, the way I'm looking at this here is the negative signs cancel out. The 160 divided by 16, that's a pretty easy one to figure out. It's going to be 10. And then we still have to divide by this 2 here. So 10 divided by 2 gives me 5. So that's how I'm coming up with that answer without using a calculator. Normally I would have to use a calculator on something like this, or I'd want to, just to save some time. But this one's not too bad to work out in your head. So we get 5. So what that tells me is it takes 5 seconds for the arrow to reach its maximum height. However, the question is not asking for that bit of information. It's a necessary piece of information that I have to find, but that is not the answer that I'm looking for here. What I want to know is, what is the maximum height? I know it takes 5 seconds to reach that maximum height. So to find the actual height that's reached in that amount of time, we have to plug that number 5 into our function. So we're going to end up getting h of 5, right? We're plugging in 5 for t, equals negative 16. In place of t, we're plugging in 5, so we'll get 5 squared plus 160 times 5 in place of t plus 4. All right. Okay, so we need to plug that into our calculator. Now this one I don't think I'm going to be able to do in my head, so let me see if I can pull up a calculator because I don't have one handy. So let me, sorry, that's from an old problem. Apologize about that. So I do have a calculator attached to my Chrome browser. So let's go ahead and plug those things in here. We have negative 16, see if this will work, times 5 squared, that's just going to be 25. Let's just write that as 25, plus 160 times 5 plus 4. And I end up getting the value of 404. All right, so this equals 404. That is the maximum height reached by the arrow. The arrow will reach a height of 404 feet after 5 seconds, and that will be the highest height that it reaches. It won't go any higher than that. From that point onward, it will start its descent back to the ground. So that's part A, so 404 feet. Part B is to find how long it takes for the arrow to reach the ground. Well, for the arrow to reach the ground, what that tells me, not in direct terms, but what you'll have to determine from that piece of information is that at the time it hits the ground, its height will be 0, right? That's what it means for it to hit the ground. The height above the ground must be 0 at that point. And so we want to plug in 0 for h and then solve for t. And what that's going to mean, by plugging in 0 for h here, we're going to have a quadratic equation to solve. So again, I wasn't quite prepared to do that. So let's go ahead and jump back to this. We need some more space to work here. So let me create a new space for us to work. We're going to plug in 0. We're going to plug in 0 for h. So we'll get 0 equals, we'll have the function that we're just working with, negative 16 t squared plus 160t plus 4. So we need to solve this quadratic function, or this quadratic equation, excuse me. And so it unfortunately will not be factorable. So what we're going to have to do is we'll have to use a quadratic formula. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2 times a. I'm using t right here in place of x because, again, our x coordinate is the variable t. Right, and that's what we're solving for. So we'll plug in these numbers. We'll have, in place of b, once again, we'll plug in 160 plus or minus the square root of, this is going to be kind of a big number, 160 squared minus 4 times a, which is negative 16, times c, which is 4. That whole thing will be divided by 2 times a, which is negative 16. And so we'll have to start whittling this down. I'm going to pause my recording here for just a second so I can get my calculator set up once again, and I'll give you some of the values here. So let me pause for just a moment. Okay, so I got the numbers here. And so here's how it works out. So we get negative 160 plus or minus the square root. The 160 squared ends up being 25,600. Multiplying these three factors together, we get positive 256. When you add those together, you end up with 25856 as the result. So 25,856 divided by 2 times negative 16, which is negative 32. We'll continue right up here. So we'll have negative 160 plus or minus, and when you take the square root of this number, it doesn't work out very nice. You end up getting a decimal, and it's actually pretty close to the 160. It's going to be 160.798 if you round to 3 decimal places, which hopefully is okay, divided by negative 32. Now, a problem you might realize was on its way is that quadratic formula gives 2 different answers. So are there going to be 2 different valid answers here? The answer to that is no. There will only be 1 valid answer. So when you split this up, you look at the plus case and the minus case. If you do the plus case, negative 160 plus 160.798, you end up getting just positive 0.798 on top, divided by negative 32, which is nonsense because that's going to end up being a negative answer, and that doesn't make sense for the problem. You can't have the arrow hitting the ground in a negative amount of time. The other solution that we get is the negative 160 minus 160.798. And when you when you subtract those, I guess, when you combine those together, you get negative 320.798 over negative 32. Dividing those because they're both negative ends up giving you the answer of 10.025 if you go to 3 decimal places. And this is the answer that makes sense for the given problem. And so we end up finding that it would take 10.025 seconds for the arrow to reach the ground.